use this index law, 1 over x power n is x power negative n. So we have to use the index law, write it in this form before I could use this formula to differentiate x power of n. So that n could be a negative number, could be a fraction. So this rule works for n could be a fraction, which we'll use next exercise, or could be a negative number. So it works for both. So let's use this. So before we do that, let's write it in index form. Call that y. So dy over dx is negative 2x power negative 3. Yep. Which is equal to negative 2 over x cubed. Yep. Got the idea? All right. That's done. So bring the negative 2. So remember, when you subtract negative 2 by 1, it's actually negative 3. Be very careful, negative 2 minus 1. Now, normally x squared is subtract by 1. It just seem to get smaller in absolute value. But this one, the absolute value gets bigger. If that, yeah. Okay, cool. All right, so be very careful with the negative. All right, let's do the next one. Again, need to write it like this. Right, 5x power negative 1. And before you differentiate, dy over dx equal to negative 5x power negative 2. Bring the negative 1 down. Subtract the power by 1, and then you get negative 5 over x squared. It's always good to write it in fact in positive index, although it may not be 100% required in the exam. So I think it's okay to leave it like that if the otherwise, unless the question say otherwise, unless the question say, oh, express it without negative index. Next one gets a bit more tricky. You need to make sure you write that as 1 over 6 times 1 over x cubed before you use this. Yep. And then you write dy dx. So have a look, like the 6 doesn't go up. The 6 in the denominator stays as a denominator. You write it as 1/6. And then you write 1 over 6 times negative 3, x power negative 4. Negative 3 and 1 over 6 get cancelled. Good. Again, it's always good to know how to do that. So even though it may not be 100% required to put the x power 4 back. All right, cool. Hopefully it's okay. So we'll do this one. Again, these are good examples where you can refer to them later on. All right, we'll continue to do the question. So how about the next one? The next one, you, again, need to split the coefficient from the pronumeral before you write 5 over 6, x power negative 2. Yep. And then you do dy on dx, 5 over 6 times negative 2, x power negative 3. The negative 2 and the 6 get cancelled, so you get negative 5 over 3. Oh, the negative 3 looks a bit too big. That's okay. Let's write it carefully. I'm sure your writing is much better than mine. Okay. Cool, cool. All right, if it's a fraction, you should split it. I think you've seen that case before. We have to split the fraction. So I'll write it like this. So you get 1/3, something like that, before you start differentiating. So you get 7 over 6 times 3, x squared, minus 1 over 6. Yep, and that gets cancelled. 3 and 6 get cancelled. You get 2, so 7 over 2, x squared. Yep, like that. All right, cool. So you got that. I want to show you another method, method 2. Method 2. Method 2 is, this is how method 2 works. You can ignore the 6, you can leave the 6 outside. So if it's only if it's a number, if it's a constant, if it involves a pronumeral, you can't do that. So dy over dx, you will notice that you will get the same answer. Exactly the same. If you expand the 1/6, you still get 7 over 2. I don't know whether you prefer this method or not, but that's available to you. And this is a good thing to know that if there's a constant outside the bracket, you can ignore it, but you have to keep it there. Okay, cool. The next two, we're going to use the chain rule. Again, this one will involve negative indices. So you can use chain rule to differentiate these. Chain rule. So how does it work? Well, make sure you write it like this. The chain rule, right? Now remember, the chain rule, we let this be u, but remember that's a bit slow, I think. I'm sure you think it's a bit slow. So dy over dx. Remember, differentiate the outermost bracket first. So you get -1, -2, right? Differentiate the outermost bracket. Whatever's inside stays the same. Then differentiate what's inside, which is -2x. Yeah. And you need to simplify it. So let's do it slowly. Negative, negative, positive, 2x. And then you do over something. So you get 2x, 1 over 4 minus x squared square. And then you get 2x. So is it possible to leave it like that? I think you can, but always, especially if you are planning to the extension 2, be able to do that. It's good. I think most textbooks write it this way, although in the exam, they will say differentiate. I think it's okay to leave it like that. But of course, show this, but if you stuff up here, I think we'll still give you the full marks. Unless the questions say otherwise, that you have to express it in using positive index, then you have to write it like this. Okay, hopefully it's okay, good. Put this up a bit so people at the back can see. This one again, same thing, writing in that index form, right? I got -3. Maybe made a mistake somewhere. Yeah, I don't think so. I think I did it right. dy on dx, 4 times -3. And remember, subtract this thing by 1, which is -4. And then differentiate what's inside. That's 2. And you times everything together, which is 6 times 4 is 24. And that will be in the denominator. Cool. All right. So again, these are the skills. And again, calculus, as the word calculus comes from the word calculate. The best way to master it, do lots of questions. It's all calculation, differentiate, do a variety of questions. Do lots of this until you just look at it, it's so easy. And you wonder your friend, oh, why is calculus so hard? Well, once you do lots of questions, it will become very easy. It will become easy. It will just become second nature to you. Yeah. Right. We do have to move on. Now, the next two involve some analysis. So it's not just asking to differentiate. You do have to do something extra. So let's read it carefully. For each function, I just give you instruction, but normally you wouldn't. You have to divide through the denominator, differentiate, find any points where the tangent is horizontal. And that's not new to us. Tangent horizontal means what? Means the derivative is what? 0, and find x, or find points. So you have to find x, y. Okay, let's do that. So you go 16 over x cubed, split it first, do it step by step. First one, 16 x to the power -3. This one you cancel, you get 24 over x squared. And then you go like this. Now, you can do it in one step, but I just do it, show more working. So to minimize the risk. As I said earlier, maybe I've said it before, if you drive a bit slower rather than too quick, you will minimize your risk of having accidents. So but in here, you just have to show full working like this, right? Got it all right. A can follow through. And after this is still fx, right? This is all algebra. After the index law, you differentiate. What do you get? You get 3 times 16 is 48. Yeah, 48, -48. X -4. Double that, you get 48 again, -3. All right, hopefully I did it right. I did. Okay, that's why I asked you to write in positive index, because if you were to solve this equation, make that equal to 0, you do have to write it without negative index, because when you solve the equation using negative index is very hard. I will write it like this, because that will help you to solve the equation. And then we have to keep going. And so how do I keep going? So we have to do the bit before, move this thing to the right. Move this thing to the right, so you get 48 over x cubed equal 48 over x power 4, right? So the key, so that's an equation you may not have seen before. It's not quadratic, it's not linear, but because you only involve two terms, so it's still you can still use your mathematical skills to solve it. And normally it just involve moving one term to the other side, and then we just have to get rid of the denominator. Get rid of the denominator, x power 4, x power 4. That get cancel. This one cancel completely. You have an x left. 48x equal to 48. Therefore, x equal to 48 over 48, which is equal to 1. So we found the x value where the tangent is horizontal. And once you find the x value, you have to find the y value. All right, how do I find the y value? Okay, so we find the y value by substituting to which one? The fx, right? Yep, hopefully that. So we find the y value. So substitute one back. 16 minus 24 over 1 cube. So 16 minus 24 is negative 8, which is negative 8. So therefore, the point where he has the tangent horizontal will be 1 comma negative 8. And the next one is very similar. Have a try. Have a try. Actually, what I'm going to do is, after this example, I will stop, but I will stop in after 30 minutes. So I want you to do the practice for this first, and then we'll move on to the square root and negative positive indices, fractional indices after 30 minutes. So you get a chance to practice before I move on to the next exercise. So we'll do 2 exercises today. As you can see, it's a short one. Have a try. Again, I really encourage you, any opportunity you can have a try, that will really help you to elevate your skill in maths. And just like if you're working in McDonald's or any part-time job, you will actually, I'm sure a lot of people will take the initiative. Let's do something extra, even though it may not be part of what you do, because that would develop your skills. And I think that's what you do in a lot of things. So if you want to be very good or achieve what you want to achieve, try it. And do not feel afraid to make mistakes, because that's how people learn, including myself, that I learn a lot through mistakes. That's why I say I do every question from the textbook, because I'll probably make a lot of mistakes or make quite a few mistakes, and I corrected them, and then I get better, and then I get better. If you keep getting better, that's how you achieve very high. Okay, all right, so make sure you speak. Okay, make sure you got that one before you differentiate. All right, hopefully you got that, and make sure you get rid of the negative index. This is a little bit harder, but it will be very similar strategy as before, where you have to move the negative term to the right and get rid of the denominator. Oh, by the way, that's from straight from the textbook. So if you want to check the answers, check the textbook example if you want, and start working on exercise. What's that? Exercise 9F. And you can check from decimals that you will get 2 stationary points. If you're interested, you can check on decimals to check that you're right. So with decimals, you can draw any graph. They will come in all shapes and sizes. So yeah, okay, let's continue. Let's not get too carried away. Get that, right, equal to 0. And move the negative term to the right. And multiply both sides by x cubed. Cancel. You get x power 4. And then divide both sides by 10. And be careful, plus or minus, because it is an even power. And this will be plus or minus 1. And then get the y value. Yeah. So to get the y value, use this one. You can use the negative index, but prefer to use that because that's easier, right? So you have to do f1 equal, and hopefully you get the answer 9. Now note that because this is an even function, can you see it's an even function? And because it's an even function, the negative and positive are the same, right? Because when you square negative, you still get positive. So there's 2.19, -19, if you still remember, even function. Okay. Any other questions? So start now. I'll show you about 30 minutes or maybe 25 minutes and move on to the next one. Okay. So do the practice now. If you fall behind, can you please try to start doing 9F and come back to chain rule later. But can you make the effort to try to do 9F first? Because it's still fresh in your memory. All right. That's good. I'll leave it like this. Thank you.